This chapter is all about trig identities. And trig identities are relationships between your trig functions. We already know about a couple. Whoops. So we already know about a couple, like the reciprocal identities and the quotient identities, meaning sine is 1 over cosecant, cosecant is 1 over sine, right? Secant is 1 over cosine, and vice versa. Cotangent is 1 over tan. Tangent is 1 over cotangent. These we already know. These are called the reciprocal identities because sine is 1 over something else. The quotient identities are these two where it says tangent is sine over cosine, cotangent is cosine over sine. So far it's nothing new, right? Meaning you have to have these memorized, okay? But you already do. So using the identities, we're gonna find these trig values. You can, in the last chapter, we did these drawing using a triangle. Now we're going to do them using identities. Okay? So I have cosine. I need to find secant. How are they related? Reciprocal. So secant of theta is 1 over cosine of theta, which is equal to 4 over 3. Okay? I have to admit, it was hard coming back to work this morning. It was, you know. But I miss this stuff. I really do. Yes. Huh? Okay, so yesterday, when I was working on the packets, specifically for section 2, I solved, all of the problems that I put on there. And man, I was having a good time. And then I'm like, ooh, let me do the ones on the honors packet. And, it was like, it was fun. It was a good time. Made me forget about my phone altogether, huh? No, they're just, I had missed it. Yeah. No, you haven't. Okay. So, secant of x is 5 over 4. Tangent of x is 3 over 4. We need to find sine of x. So I'm given secant and tangent. I need to find sine. So the strategy is, and this will help you for the rest of the chapter, the strategy is, what's a way that secant and tangent are related to sine? Okay, so how are secant x and tangent x related to sine? Well, I know, first of all, that, well, I don't know that, but okay. I know that tangent of x is sine x over cosine x, right? And what's secant x? 1 over cosine x. So, if I know what tangent is, and I know what cosine is, I can easily find sine. Okay? So, if secant of x is 5 over 4, cosine of x is 1 over secant of x, 4 over 5. We're okay so far? Okay. Now, so what's sine of x? If I multiply both sides by cosine, what's sine of x equal to? Cosine x times tangent x equals sine x. So now let's plug in our values. Cosine of x is how much? 4 over 5. Tangent of x is how much? 3 over 4. Meaning, sine of x is 3 over 5. Now, you can skip a lot of the intermediate steps. I just did it this way to show you guys the line of thinking. But yeah, you could skip a lot of the intermediate steps. Okay, so now here, this is a big deal in math. Here is an angle theta. And you put it on the unit circle, and you draw a triangle, and we went over this again and again and again. You have a horizontal side and a vertical side. The horizontal side is cosine of theta. The vertical side is sine of theta. Remember from chapter 4? Say yes. No. Yes. So, okay. Now this is a right triangle, right? If you have a right triangle, what does the Pythagorean theorem say? Right. In this case, the horizontal is x, vertical is y, and the hypotenuse is 1. So the Pythagorean theorem would say x squared plus y squared equals 1 squared, or 1. Okay? Now, if you want to use cosine and sine instead, then it's sine squared plus cosine squared equals 1, right? Y squared plus x squared equals 1. Sine, if you use the other labels, the alternate labels, sine squared plus cosine squared equals 1. And if you write it simply, then it's this. This is called the Pythagorean identity. How important is this? It can't get more important than this. This is the Pythagorean identity. Now, you have to memorize this. You have to. Okay? Now, if you take sine squared theta plus cosine squared theta equals 1, okay? And just for fun, I'm going to do something to this, just for fun. I'm going to divide every single term here by cosine squared theta. Why am I doing that? Because I want to have fun. So let's see what happens when we do that. What's sine squared over cosine squared? Tangent squared theta. Plus, no. Cosine squared over cosine squared is 1 equals, what's 1 over cosine squared? Secant squared theta. When you do that, you get the second Pythagorean identity, this one. Okay? So all I did is take the first one, divide it through by cosine squared. Now, I'm going to take the first one again, this time I want to divide it through by sine squared theta. Sine squared over sine squared goes away. You get 1 plus, what's cosine squared over sine squared? Cotangent squared theta equals 1 over sine cosecant squared theta. That gives you the third. Okay, so what's cotangent? Cotangent of theta is cosine over sine, right? So how do we find our sine theta and cosine theta? How would we do Pythagorean theorem? Can we do it using a triangle? Okay, let's do it using a triangle first. Okay, where is the, so go ahead and do that using a triangle. So it's adjacent over opposite, right? And how much is the hypotenuse? Square root of 5. So sine of theta, root 5 over 5. But it's going to be negative. And cosine of theta, negative what? 2 root 5 over 5. Okay, so we did this using the methods used in chapter 4. Here, we're going to do it using trig identities. Okay? Here's how you do it using trig identities. I want to find sine and cosine. I have cotangent. Go to your identities and figure out how is cotangent related to sine or cosine. Well, I'm going to use this one. Okay? Cotangent squared plus 1 equals cosecant squared theta. Okay, so what's cotangent? It's 2. Cotangent squared is 2 squared plus 1 is equal to cosecant squared theta. Okay, 5 equals cosecant squared theta. Take the square root of both sides. Cosecant of theta is plus or minus root 5. Now, cosecant is like sine. Is that right? Do I want sine to be positive or negative in this quadrant? In this quadrant, sine is negative. So I say cosecant of theta is negative root 5. What's sine of theta? Negative 1 over root 5. Negative root 5 over 5. Okay? Now, I still have to find cosine. I know that cotangent of theta is cosine theta over sine theta. So, cosine theta equals sine theta times cotangent theta. What's cosine theta? Negative root 5 over 5 times cotangent is 2. Okay, so we get the same answers. Now, do you have to do it this way? For this chapter, yes, you have to do it using identities, but it's the same idea. Okay? Yes and no. Yeah. Okay, cofunctions. So cofunctions are this. You know how you have sine and cosine, right? Secant, cosecant. The fact that one is co of the other is not just a coincidence. They're related to each other. So basically, sine of A is equal to cosine of B, okay, if one is 90 minus the other. So for example, if I have sine of 10 degrees, okay, what's 90 minus 10? 80. Cosine of 80 is the same thing, okay? So if I have sine of 30 degrees, what's 90 minus 30? 60. Cosine of 60 is the same thing. Okay? Let's do one with another identity. Suppose I have tangent of 20. What is that equal to? Cotangent of what? What's 90 minus 20? 70. Okay? So if I have tangent of 50, that's the same as cotangent of what? 40. Okay? It's always 90 minus this one. Okay? That's a cool little cofunction identity. That's what all this means. And you can do the same thing with pi's, except instead of 90, it's pi over 2. Okay? All right. Odd and even identities. We've touched on this for a little bit. If your angle is negative, okay, the sine is an odd function. So what it does is it takes the negative and spits it back out. All right? If you have a negative angle, the cosine engulfs the negative, makes it go away. Tangent is like sine. It takes the negative outside. So for example, if you have sine of negative 30, that's negative sine of 30. If you have tangent of negative 40, it's negative tangent to 40. Cosine makes the negative go away. Tangent of negative 50, cosine, is just cosine of 50. Okay? Cosine of negative 50 is just cosine of 50. Okay. So suppose cosine of x is this. What's sine of x minus pi over 2? Okay? So if you go back there, we want sine of x minus pi over 2, right? All right, look at my identity. Sine of pi over 2 minus x is cosine. So how do I change that into this? How do I change this into that? Do you see how this is x minus pi over 2, this is pi over 2 minus x? One is the negative of the other, right? So if I have a negative angle with the sine, what happens to the sine? It becomes negative. So you put a negative out front here. Okay? So make the angle negative. So you put a negative there. Now, what's sine of pi over 2 minus x? Sine of pi over 2 minus x is what? Cosine of theta. So this is negative cosine of x. Okay? How much is cosine of x? Negative 0.75. So this is negative 0.75. Okay? Yeah. Okay, so let's simplify these. This is going to take us right to the next lesson. To simplify means you bring it to a form where you can't do any more operations. One good trick is rewrite it in terms of one function or in terms of sine and cosine only. For this one, for the first one, you have a 1 and a sine squared x. Whenever you have a 1 minus or plus another 1 squared, you always want to go back to your Pythagorean identities. What's the Pythagorean identity with sine squared x? It's sine squared x plus cosine squared x equals 1. Now, here we have 1 minus sine squared x. What happens in the identity if I subtract sine squared from both sides? Cosine squared x is 1 minus sine squared x. Perfect. That means this is cosine squared x times 1 over cosine x. Look at what happens. 1 cosine from here cancels out with this one, and I'm left with cosine x. See what a cute little answer you end up with? Very cute. Now, look at how cute this answer is going to be. Part B. Like the formulas. We don't call them formulas, we call them identities. They're relationships between the functions. This one, a good line of attack when you have cosine, sine, tangent all mixed is try to write everything in terms of just sine and cosine. Cosine x for the first one.
Simplify, not solve.
Yeah. So this is cosine x times, what is tangent? Sine x over cosine x minus sine x cosine squared x. See, automatically the cosines cancel, so already we know that we're on the right track. So now I have sine of x minus sine of x cosine squared x. I can factor out a sine of x. That's always a thing, factoring things out. If I factor out a sine of x, then I have 1 minus cosine squared x. Now, back to the identity. Sine squared x plus cosine squared x equals 1. So 1 minus cosine squared x is sine squared x. So this is sine of x times sine squared x. So the final answer is sine cubed x. Come on. Like, who would have thought that all that would equal to that? This is where this chapter gets fun. Okay?
Is it not a multiplication there? It's one term, sine x, cosine squared?
No, sine x times sine squared x.
So why doesn't the sine go in?
They don't, because it's one sine times another sine times another sine.
Oh, so that's
Cubed x.
I'm confused on how you got to the part that's
Okay, you see the identity here? Sine squared plus cosine squared equals 1. If I subtract cosine squared to here, 1 minus cosine squared is sine squared, and you plug it in there. Okay, when you have something like this, it's always the same. Common denominator. Common denominator here is going to be 1 minus secant x, 1 plus secant x. Now, remember how we did common denominators? Take the first denominator, it goes into this one, 1 minus secant and 1 minus secant cancel. You have this left times secant. So it's secant x times 1 plus secant x minus secant x, 1 minus secant x. Now we distribute. Common denominator. Now we distribute. Secant x plus secant squared x. No. Cancel what out? No, because there was a minus in here. No. No. Minus, minus. Plus secant squared x over, now, what's 1 minus secant x, 1 plus secant x equal to?
1 minus secant x squared.
There you go, 5 brownie points to Brooke here. Okay, look. So if I have 1 minus x, 1 plus x, what is that equal to? 1 minus x squared. Now I have 1 minus secant, 1 plus secant, difference of squares. Okay? 1 minus secant squared x. Here. Okay? Now, magically, the secants go away. And on top I have secant squared plus secant squared. How many secant squares? 2 secant squared x over, what is this equal to? Trig identity.
Tan squared?
That's the identity. Secant squared x minus 1 is tangent squared x. Okay,
Because that's
this is the identity from the first page. So tangent squared x equals, negative tangent squared x is 1 minus secant squared x. Okay? Okay. So this is the identity, right? Yes. Okay. Now, I'm going to take secant squared to this side, right? So it'll be 1 minus secant squared x equals tangent goes to that side, becomes negative tangent squared x. Try it out. Because this is the negative of that. What's secant squared x minus 1? Tangent squared. But this is the negative, so it's negative tangent squared. Okay? So this is negative tangent squared x. Now, is this simplified? Oh no. What's secant equal to? 1 over cosine. So 2 over cosine of x squared over negative sine squared x over cosine squared x. What's tangent? Now, 2 over cosine squared x times negative cosine squared x over sine squared x. If you're comfortable skipping that step, you can. This is negative 2 over sine squared x, which is negative cosecant squared x. Why do you look like you're going to have an aneurysm?
It's an aneurysm.
Okay, I'll do it again. Okay, so 1 plus tangent squared x is an identity that we saw here. It's secant squared x. And this is, hang on, this is cosecant squared x. So here, why don't we change to sine and cosine? So on top I have 1 over cosine squared x. On the bottom I have 1 over sine squared x.
So it can't be 1 over cosine.
No. No, look. This is equal to 1 fraction divided by another is 1 times the reciprocal. 1 over cosine squared x times sine squared x over 1. Okay? Now, what I have is sine squared x over cosine squared x, which is what? There you go. That's the answer. Put your cell phones away, please.